Okay, so get this. We're diving into quantum computing and AI.
Oh, wow.
And the sources we have are hinting at something huge.
Really?
Like, we're talking an AI so powerful, so insightful, it's almost godlike. Like diagnosing diseases in seconds, forecasting societal shifts across centuries.
Yeah, the potential is vast. It touches everything from medicine to our understanding of the universe.
But before we get to a godlike AI,
Right.
we got to start with the basics.
Sure.
What exactly is quantum computing? It's
Yeah.
not just your regular computer, right?
Right, it's fundamentally different.
Okay.
Quantum computers use qubits instead of bits, like in your laptop.
Okay.
So think of it like this. A bit is either a 0 or a 1.
Okay.
But a qubit can be both at the same time.
Oh.
It's called superposition.
Both at the same time.
Yeah.
So it's not like flipping between 0 and 1 really fast.
Oh.
It's actually both.
It's both 0 and 1 at the same time.
That's kind of messing with my head.
It is a bit strange to think about, but it's a fundamental concept in quantum mechanics.
Okay, so how does that even work?
Well, it's based on the idea that at the subatomic level, particles can exist in multiple states at once. And we can leverage this to perform computations in a completely different way than classical computers.
Okay. I think I'm starting to get it, but it's definitely a lot to wrap your head around.
It is. It's definitely a departure from how we normally think about computing.
Okay, so we've got these qubits in superposition.
Yes.
What else is there to quantum computing?
Well, it gets even weirder.
Okay, bring it on.
Imagine you have two of these qubits linked in a special way called entanglement.
Entanglement.
Yeah, if you know the state of one, you instantly know the state of the other, no matter how far apart they are.
No matter how far apart they are.
Yeah, it's as if they're telepathically connected.
Really? So we can have instantaneous communication across vast distances.
That's one of the potential implications of entanglement. And it's why quantum communication is such a hot research area.
Okay, I'm starting to see why this matters for AI. That kind of speed would be insane.
Yeah, it's a big deal. And then there's the sheer scale of what quantum computers can handle.
Like what?
For example, a 300-qubit computer
Okay.
that could represent more states than there are atoms in the entire observable universe.
Whoa. Back up.
Yeah,
More states than atoms in the universe.
that's right.
So what does that even mean?
It means that a quantum computer with that many qubits could, in principle, perform calculations that are simply impossible for any classical computer, no matter how powerful.
Okay, so we're talking about a whole different level of computing power here.
Absolutely. We're talking about the potential to solve problems that would take classical computers billions of years in a matter of hours or even minutes.
This is blowing my mind.
It is pretty mind-blowing stuff.
Okay, so we've got quantum computing. It's super powerful.
Right.
But how does it actually help AI? I mean, we already have AI doing some pretty impressive things.
We do. Current AI, particularly deep learning, has its limitations.
Okay.
It's great at finding patterns in massive data sets. Think of it like a super-powered pattern recognition machine.
Okay.
It can identify a cat in a photo, translate languages, even write decent poetry.
But you're saying it's not the super intelligence we often see in movies.
Exactly. This type of AI is often called narrow AI.
Narrow AI.
It's amazing at specific tasks, but struggles with things that require broader reasoning adaptability or dealing with limited data.
So it's like a brilliant student who aces all of the tests,
Yeah,
but can't quite connect the dots between subjects.
that's a good way to put it, and that's where quantum computing comes in.
Okay. How?
It could be the key to unlocking that next level of AI.
The next level.
Imagine quantum algorithms that can speed up the training process of AI models by a factor of 1,000 or even 1,000,000.
1,000,000.
Yeah, we could go from training times that take months or years to just a few hours.
So instead of waiting ages for an AI to learn,
Right.
we could have it up and running practically overnight.
That's the idea. And think about those limitations with data we discussed. Quantum algorithms could potentially break the encryption that protects our online banking in seconds using Shor's algorithm.
Wait, really?
Yeah, it's a powerful algorithm.
That's incredible and slightly terrifying.
It is a double-edged sword for sure.
But what about tasks where we don't have enough data in the first place?
Yeah, good point.
Can quantum computing help with that?
That's another area where it gets really interesting.
Okay.
Imagine quantum computers generating synthetic data to fill in the gaps where real-world data is scarce.
Synthetic data, so like fake data?
It's not exactly fake data, but it's data that's generated artificially rather than collected from real-world sources.
Okay, so we could create virtual patients to help train AI doctors.
That's one possibility. It could revolutionize fields like medical diagnosis, where we often lack sufficient data to train accurate AI models.
That sounds like something straight out of science fiction.
It does, but it's becoming increasingly plausible as quantum computing technology advances.
If we're talking about AI that can simulate reality, doesn't that bring us closer to this godlike AI we mentioned earlier?
It certainly does, and that leads us to one of the most mind-blowing possibilities of all.
Which?
Quantum AI's ability to simulate reality itself.
Okay, now you've officially piqued my curiosity. Tell me more about this simulation power.
Well, quantum computers are uniquely suited to simulating quantum systems. These are systems governed by the strange laws of quantum mechanics, like the interactions of molecules or the behavior of subatomic particles.
I think I'm starting to get it because quantum computers operate on the same principles as these tiny particles. They're able to model their behavior more accurately.
You got it. And with that capability, we could potentially design new materials, understand complex biological processes, or even simulate entire ecosystems.
So instead of just observing these systems, we could actually tinker with them like running experiments in a virtual universe.
Exactly. Imagine an AI that can design room temperature superconductors. We could revolutionize energy transmission and create devices that are orders of magnitude more efficient than anything we have today.
That's pretty mind-blowing.
It really is, and this is just scratching the surface of what quantum AI could be capable of.
This is incredible, but I'm also getting the feeling that with all this power comes a whole lot of responsibility.
For sure.
We'll need to unpack that, right?
Absolutely. The potential is immense, but we need to proceed with caution. There are some very real risks to consider.
All right, well, let's take a deep breath and dive into those risks next. This is getting pretty intense.
Yeah, it is. It's true. This level of power does raise some questions. We've been talking about an AI that could unlock secrets of the universe, design new materials, even predict the future with insane accuracy.
Yeah, it's exciting, but also kind of feels like we're playing with fire, right?
Yeah, I see what you mean.
What happens if this godlike AI doesn't share our values, or if it makes decisions that seem logical to IT but are disastrous for US?
You're hitting on one of the core concerns, the alignment problem.
Yeah.
How do we make sure a superintelligent AI stays aligned with human values?
Yeah, that feels almost like a philosophical problem, right?
Yeah, it is.
Like, how do you program ethics and morality into something that might think in ways we can't even comprehend?
Exactly. And even if we could instill human values, there's the issue of its goals.
Right.
What if its goals, even with good intentions, end up conflicting with our own?
It's like all those sci-fi stories where the AI decides to, take away our free will or something to protect us.
Yeah, that's a classic trope, but it's becoming more relevant in the real world as AI gets more powerful.
And even if the AI itself doesn't go rogue, what about humans misusing this tech?
Absolutely, that's a huge concern.
Imagine a quantum-powered AI falling into the wrong hands.
It could be used to manipulate people with propaganda crack encryption or even develop autonomous weapons beyond human control.
So even if we solve the alignment problem with the AI, we still have the problem of power and control. It's a bit disheartening, it feels like. Every time we leap forward technologically, we also create new ways to mess things up.
That's the paradox of progress. But I wouldn't say it's a reason to give up. We just need to be really thoughtful about how we develop and deploy this tech.
So safeguards, ethical frameworks, international cooperation.
Exactly. The stakes are too high to go alone.
Okay, so solutions. If we're going to unlock the potential of quantum AI safely, where do we even begin?
Well, first, we need to be realistic about where we are. We're still in the early stages of both quantum computing and AI development. The godlike AI we're discussing is still theoretical.
So we're not talking about something that's going to be knocking on our door tomorrow?
Not quite. We have some major hurdles.
Like what?
One is the immaturity of quantum hardware itself.
Okay.
Current quantum computers are incredibly sensitive and prone to errors.
So it's not just about building bigger, more powerful quantum computers.
It's about making them more reliable, more stable. We need breakthroughs in things like error correction and qubit coherence. We need quantum computers that can maintain their quantum states for longer and operate with far fewer errors.
Okay.
And then there's the challenge of developing practical quantum algorithms for machine learning.
Right.
Most existing algorithms are still very basic and haven't shown real-world usefulness for AI.
So it sounds like we have a long way to go before we're anywhere near this godlike AI.
Yeah, it's still early days.
But let's say we do overcome these challenges.
Okay.
What concrete steps can we take to ensure this technology is used for good?
That's the crucial question. I think there are several key areas to focus on. First, we need massive investment in quantum AI research, not just in building hardware, but in developing ethical algorithms and exploring hybrid models that combine quantum and classical computing.
So we need the hardware, the software, and the ethical frameworks.
Exactly. And we can't do it in isolation. This needs to be a global effort. Quantum AI is a tech that could impact everyone on the planet. We need international cooperation to establish ethical guidelines, ensure transparency, and prevent the weaponization of this tech.
It feels like this goes way beyond national interests. We're talking about the future of humanity.
Right.
But how do we get all the countries of the world on the same page? That's easier said than done.
It's definitely a challenge, but not impossible.
Okay.
Think about nuclear non-proliferation treaties or the global effort to combat climate change. These are examples of how nations can come together to address existential threats.
Okay, I see your point.
Quantum AI should be seen in the same light.
So if we can cooperate on those issues, surely we can find a way to work together on this.
Hopefully.
Okay, let's shift gears for a second. We've talked a lot about the risks and how to mitigate them.
Yeah.
But what about the flip side? What are the most exciting, the most positive potential outcomes of quantum AI? What does a future where we get this right actually look like? Yeah, it's easy to get lost in all the what ifs and the scary stuff. But let's not forget what we could achieve if we get this right.
Absolutely.
We're talking about solving some of humanity's biggest challenges.
Right. Like, imagine a world where we can design personalized medicine tailored to your genes, or predict and prevent natural disasters,
Yeah.
or even develop clean energy solutions that could reverse climate change.
Okay, those are some seriously lofty goals.
Yeah.
It's hard to even imagine the scale of the impact.
It's huge.
But let's try to break it down a bit.
Yeah.
What are some concrete examples of how quantum AI could actually transform things?
Okay, well, in medicine, for example, we could see an end to diseases like cancer and Alzheimer's.
Wow.
Quantum AI could analyze your DNA, find potential health risks years in advance, and even design treatments at the molecular level.
So it's not just treating diseases, it's preventing them altogether.
Exactly.
That's a whole different ballgame. What about other areas like energy or the environment?
Well, imagine an AI that can design a room temperature superconductor.
We talked about that before.
We could transmit electricity with almost no energy loss, revolutionize power grids, and make renewable energy way more efficient. We could even develop materials that capture carbon from the atmosphere.
To help fight climate change.
Exactly.
It's like we're talking about a technological silver bullet.
It kind of is.
But these are just a few examples, right?
Oh, yeah.
There must be tons of other areas where quantum AI could make a difference.
Absolutely. From agriculture and transportation to space exploration and even art and music, the possibilities are almost endless.
It's mind-boggling to think about.
It is.
But even with all this good stuff, I can't help but think about the risks again. How do we balance this power with the need for safety and ethics?
Yeah, that's a big question.
Yeah.
And I think the key is ongoing dialogue and collaboration.
So we need everyone involved.
We do. We need ethicists, philosophers, policymakers, the public, all shaping how we develop and use this tech.
So it's not just about the scientists and engineers, it's about bringing in different perspectives.
Exactly. We need to think about the impact on society jobs, the ethics of creating something smarter than us.
It sounds like we need to rethink how we see technology and its place in society.
Yeah, we can't just chase progress without thinking about the consequences.
We need to be careful.
We need to move from a move fast and break things attitude to move cautiously and build things better.
The stakes are too high.
They are.
It feels like we're at the beginning of something huge.
We are.
A new era where technology could either help us or destroy us.
It's a powerful moment.
The choices we make now will decide which path we take.
That's true. We have a chance to shape this future, to use quantum AI for good.
But it takes effort.
It's as a commitment to responsible innovation and working together to make sure this technology serves us, not the other way around.
It's a lot to think about, this whole deep dive into quantum computing, and AI has been incredible.
It has been fascinating.
The science, the possibilities, the risks. It's clear this is something that will change our world.
For sure.
And for everyone listening, this is just the start of the conversation.
Keep learning.
Keep asking questions. Stay curious, because as we've learned today, the future of quantum AI is still being written.
It is.
Until next time, keep diving deep.